Hello, this is Gary Parker. I'm going to take a look at completing the square with you right now. Let's take a look. So completing the square is based on the idea that if you take a binomial, like I have here, that's this guy, and you square it, multiply it by itself, you have to distribute each pair, and you end up in the middle with the same number added or subtracted. So here I have two 5x's, they happen to be negative, so I get a negative 10x. Right, so that middle coefficient is twice whatever number I started with here. And the last term is always the perfect square of that. So based on that observation, we can solve equations that we couldn't before. So completing the square is about looking at this procedure in reverse, re-engineering that perfect square to solve an equation. So here I have a quadratic equation that's not factorable. And it's set equal to 0. So, we'd like to use the zero product rule, but we can't because we can't make this a product. So we're going to re-engineer a perfect square. So to do that, we take the observation that the middle term is double some special number. So to undo that, we take the middle term and cut it in half. So -4 is my middle term, and I cut it in half. That gives me -2, right? That number right there, when I cut -10 in half and get the -5, that's the magic number that goes inside the square. But I need the right number over here. That number is always going to be the square of that halved number. So 4 is the number I want right here, not 9. So what we do is we just move that 9 over to build our perfect square trinomial. So I have x squared minus 4x, leave a little space, equals -9. In this case, I want a 4 on this side. That's the magic number that makes this a perfect square. Now I can't just add 4 on one side of the equation, I have to add 4 on the other side of the equation. So next thing I note is that I've created a perfect square. X minus 2 in parentheses squared, if you multiply that by itself, you'll get x squared minus 4x plus 4. So that's, again, this procedure in reverse. Now we have a new number on the other side. So in this case, I'm going to get a -5 on the other side, which is a good thing and a bad thing at the same time. Depends on how you look at it. Let's turn it into some sunshine. It's a good thing. Next thing we want to do, because we have a perfect square on one side, is we can get rid of that perfect square by taking the square root. I'm going to take the square root of both sides. Square comes in contact with a square root. They sort of kind of cancel. So that should leave behind an x minus 2. Now the catch is, if you square a number, you lose track of the sign. So we have to compensate from that by putting a note on the other side that it could have been positive or negative. On the other side, I have the square root of -5. So let's think about that for a second. My scratch paper off to the side. So square root of -5. So as we learned in the last chapter, square root of a negative is I. So that negative sign pops out as an I. Now the 5 is still trapped in the root. 5 doesn't factor, so it's stuck. So I'm going to write this as I times the square root of 5. Now you can write it in the other order. You can say it's the square root of 5 times I, but if you're a sloppy writer, you don't want to accidentally write it and make it look like, let's not put the hook on there, is the I in the root or not? I don't know. That's not good. So be very careful. Put the I in front just to be safe. All right, so we're almost done with this thing here. Now we just add that 2 to the other side, and I like to write it in front. So I would write x equals 2 plus or minus I times the square root of 5. So there's two answers here. One is 2 plus I times the square root of 5, and the other is 2 minus I times the square root of 5. And there isn't really an easy way to check this. The only way we have to check it is to take I say plus the square root of 5 and plug it in everywhere I see an x in the original and hope it cleans up. And you've done problems like that in the last chapter to check. So feel free to do that to make sure it's right. But I feel pretty confident with that. Let's try another one. So here I have another quadratic equation. This time I don't have 0 on the other side. And the question is, -6 the magic number that makes it a perfect square? Well, the only way to check is to take your middle term, -5. Let's have a little scratch paperwork on the side. Cut it in half. Now, you could do division, take 2 into -5, and see that's -2.5. But what I find is working with decimals when you're completing the square is not usually helpful, so I'm not going to do that. I'm going to leave it as a fraction. Okay, once I take half that middle term, I want to square it. It's the next step in completing the square. -5 times -5 is 25, and 2 times 2 is 4. So 25/4 is the magic number I want, not 6. So then I'm just going to move that 6 out of the way, bring it over to the other side here, add it, excuse me. So then I get x squared minus 5x, leave a little space, equals -3. And then we want to take and add that 25/4 to both sides. I'm going to add 25/4 here, because that's the magic number to make this a perfect square. And I'll have to add 25/4 here to keep the equation balanced. Two things that happen next. This thing is now a perfect square, because I found the magic perfect square there. So it becomes, I think I messed up my pen, x minus, and this is the first number I want, 5/2. That, if you multiply this by itself, you get that part above. On the other side, we got to clean this up a little bit. So let's see, we need a common denominator, so we'll write that as 3/1. Common denominator should be 4. Multiply top and bottom by 4. Let's see, 3 times 4, that's a -12. -12 plus 25 is 13, so I get 13/4 when I take -3, excuse me, and add 25/4. Getting close to done. I'm ready to take the square root of both sides. So square root this left side, square root the right side. Square root and a square sort of cancel. I can write x minus 5/2. The trick is that since the square was first, I lost track of the sign of what x was. So I have to put a plus or minus. On this side, I can think about that as the square root of 13 over the square root of 4. That was one of our rules from last chapter. And that's nice because the square root of 4 is really 2. So this is a plus or minus square root of 13 over 2. Square root of 4 is 2. Be careful when you write this down. You want to be clear that the 13 is in the root, the 2 is not anymore. Since this is a minus 5/2, I can add that 5/2 to the right side, so it becomes a positive. And now I have my answers. I have 2 answers here. One of them is 5 plus 5/2 plus square root of 13 over 2. The other one is 5/2 minus the square root of 13 over 2. Now, this is one that is actually pretty easy to check. I can check on a graphing calculator. So I'm going to get Desmos open here. And to do this, easiest way to do it is to use function notation. So write f of x, f of x equals, and then let's see, what did we have? We had, where'd you go? X squared minus 5x minus 6 equals -9. All right, so x squared minus 5x minus 6. And I can't put the equals -9, but here's that parabola. And I want to know what happens when I plug in one of those numbers. So I want to, into the function f, I want to plug in 5/2. Let's say we could do the plus the sqrt square root of 13, get out of the root, divide by 2, and oops, I don't have parentheses there, need them out here. Desmos says when you plug in 5/2 plus the square root of 13 over 2, you get -9, which is exactly what I'm supposed to get according to my original equation. So this one of these answers checks out. If the plus checks out, the minus will check out. Just another note on this. Since I have a common denominator, I could also say everything is over 2, and I get 5 plus or minus the square root of 13. All right, let's do one more. All right, so this one's a bit more complicated. Notice it has a 2 in front of the x squared. There is no greatest common factor here, so I'm stuck with the 2 for the moment. Turns out this sucker doesn't factor. You can try if you'd like. So first thing I'd like to do is to make it like the other problems, I want to get rid of that 2. So that means I have to divide everything by 2. Okay, so I divide this side by 2, I divide that side by 2. All right, what do we get? We get a nice 1x squared, or x squared. I'm going to view this as negative 3 halves times x. And then 2 goes into negative 6 minus 3 times. 0 divided by 2 is 0. All right, so now it looks more like the other ones. So completing the square, remember the first step is to take that middle coefficient, negative 3 halves, and divide by 2. Now, remember, dividing by 2 is the same as multiplying by a half. So that means one of my magic numbers is negative 3/4. Second step is to square that number. So that's going to give me negative times a negative is a positive 9 over 16. So that's my magic number. So get rid of this 3 here by adding it to the other side so we can throw our magic number in. So I now have x squared minus 3 halves x, leave a little space, equals 9/16. And our equals 3. Getting ahead of myself. And then our magic number is 9/16. So if I add a 9/16 here, I have to do the same thing on the other side to keep it balanced. The whole point was that this is now a perfect square. It's the square of x minus 3/4. Little arithmetic on the other side, 3 over 1. Common denominator would be 16, so we multiply 16 top and bottom. 3 times 16 on a good day is 48. 48 and 9 is 57, so I get 57/16 on the other side. Since we have our perfect square, we can go ahead and take the square root of each side. And so now I get x minus 3/4. And we just got to live with fractions sometimes. It's all right. Now, 57, if you try and factor it, let's see, 5 plus 7 is what? 12. Oh, 3 goes into that. 3 goes into 5 once, with 2 left over. 3 goes into 27 9 times. Okay, it's 3 times 19, but that doesn't help. 19 doesn't factor, so that means I can't clean up the square root of 57. But the square root of 16 cleans up nice, right? So I'm going to have a new fraction. I'm going to call it the square root of 57 for the numerator, and my denominator is the square root of 16, or 4. Hey, it matches that denominator. Hey, that happened last time, too. Interesting. All right, almost done. So let's pick up on another page. We've got x minus 3/4 equals the square root of 57/4. And, ooh, yeah, you're right. I missed that. Whenever we take the square root of a square, we got to compensate on the other side with a plus or minus, because when you square a number, you lose track of whether it was positive or negative. So I don't know. So I get to adjust, plus or minus. So x is going to be adding that 3/4 to the other side, plus or minus square root of 57/4. Since there's a common denominator, you could take it one step further. You could write it as 3 plus or minus the square root of 57 over all over 4, like that. And we could check by plugging one of these in. So there's 2 answers here. One of them is 3 plus the square root of 57, all over 4. The other is 3 minus the square root of 57, all over 4. On a regular calculator, if I wanted to type that, it would have to be parentheses 3 plus the square root button. Sometimes that needs parentheses. 57, close the square root, close the numerator, and then divide by 4. Okay, so that's calculator version. Similar for that one right there. So you can plug that into a calculator. That gives you an approximate x value. Take that approximate x value, plug it back into the original, not any variation, and see if it gives you what the other side says it should. So you can check on a Desmos or some other graphing calculator. All right, one more thing I want to show you before we go off and do our own thing. Blank page. There we go. This is what's called the quadratic formula. So if you start off with something that looks like this, then x has to look like that. So we're going to check that formula on the problem we just did. So on the problem we just did, we had, wrong pen, we had 2x squared, minus 3x minus 6 equals 0. So I'm just going to make a note. A is 2, B is negative 3, C is negative 6. Oops, C, not 6. Double check that I copy those right. 2, negative 3, negative 6. 2, negative 3, negative 6. Yeah, so then I just carefully plug in here. So the quadratic formula says x should be the opposite of whatever b is. So b is negative 3. That means I want a positive 3. Plus or minus this big old square root. First it says to square b. Okay, let's see. So negative 3 times negative 3 is 9. I usually feel comfortable doing that and this in my head. The next step is where I slow down. I've got minus 4 times a, which is 2, times c, which is negative 6. All of that is divided by 2 times a. So 2 times 2, that would be a 4 in the denominator. All right, so then we got to clean up this. It's called the radicand right here. So what do we have? Well, we've got a negative 4 times a negative 6 ultimately. So that means this is going to be a positive there. Negative times a negative is a positive. 4 times 2 is 8, times 6 is 48. So I'm going to have a 9 plus 48. On a good day, that's 57. So the quadratic equation says the answer should be 3 plus or minus the square root of 57 all over 4. Whoa, that's what we found over here. No, not there. There. Cool. So completing the square is the procedure that leads to developing the quadratic formula. So if you went through those steps I went through a few minutes ago on this, dividing out that first term, taking half the middle term and squaring it. So if you repeat that same set of steps but leave that as a, b, and c, this is what it will clean up to be. That's where the quadratic formula comes from, the completing the square. Sometimes the quadratic formula is an easier way to get a pair of answers. But other times, like especially if the middle coefficient is even, divide by 2, that's super easy, right? You'll find that this is completing the square is easier than the quadratic formula. So my philosophy is if I have a 1x squared and an even middle term, I'm going to complete the square like I did here. Otherwise, I generally will use the quadratic formula. All right, have fun, do good math. See you in the future.